Okay. Okay, so thank you, everybody. I have less to say actually than Lisa did, but I do want to give a little bit of background to the CCQM and our perspective on using mass spectrometry to measure radioisotopes. So the CCQM, just as a very quick background, is the Consultative Committee for Amount of Substance, Metrology and Chemistry and Biology. Covers a broad range. The 9 technical, I'll call them technical, working groups that comprise the CCQM are shown on the left-hand side of the screen. And you can see we cover a very broad range of activities from cell analysis, that is biological cells, to classical methods like electrochemistry, and also part of the electrochemical analysis working group is classical analytical chemistry, things like gravimetric analysis and titration, gas analysis. The inorganic analysis working group is the one that I chair. The isotope ratio working group is the one that Zoltan Mester chairs. Nucleic acids, organic analysis, protein analysis, and surface analysis. So techniques like secondary ion mass spectrometry and some microscopy is included there. So the CCQM covers a broad range of activities. For our workshop today, the 2 working groups which are most in view are the one that I chair, the inorganic analysis working group, and the isotope ratios working group, which is chaired by Zoltan Mester from NRC. The primary thing that I want to bring out on this slide is the space in which we work in these 2 working groups. Our typical measurands, or the things that we're trying to measure, is in the inorganic group, the elemental mass fraction. So, you know, what we're talking about there is the mass of copper that is present in a per mass of steel, for example, or the mass of some other element in the per mass of a food item, that sort of thing. Sometimes we do get into somewhat varied measurands. We occasionally are more concerned about elemental amount fraction, but that's kind of rare. Less rare is species of elements, where we are concerned about whether the arsenic present is arsenic 3 or arsenic 5 or some other organoform of arsenic. And the isotope ratios working group, which actually used to be part of the inorganic analysis working group. It was split off separately about probably 4 years ago. But isotope ratios, obviously, by the title, is the measurand that is of interest there. Just in terms of the types of mass spectrometry that we use in these working groups, and by the way, we use a pretty wide range of techniques in the inorganic analysis working group, but I've only listed here the mass spec instrumentation that we typically apply, since that is the context of our workshop, is ICP-MS, inductively coupled plasma mass spectrometry. Various forms of that going back to the old single quadrupole. Most of those nowadays come with collision cells or reaction cells to reduce isobaric interferences, but still, it's an old instrument, but it's still very useful. And you can actually still buy new ones of that sort, because it's a cheaper alternative to the others. Triple quadrupole is becoming more and more important. high resolution sector type instruments and multi-collectors are used in some cases, for example, for isotope dilution mass spectrometry. In the isotope ratios working group, of course, this is all really about multi-collectors. I failed to mention one here that I should have mentioned, and that's an isotope ratio mass spectrometer, which is meant for gas source type applications. Sorry, I forgot to put that one on for you IRMS people. I apologize for the overlook. But the idea with these mass spectrometers is simultaneous detection to get the best precision that is possible with measuring the various isotopes of an elemental system. Typical figures of merit that are important for today's discussion, I think, as best I can understand the ones that are important, are that the limits of detection are very good for these techniques, going down to below a nanogram per kilogram, and our expanded relative uncertainty can also be quite good, from at least for chemical analysis, from 0.3% to maybe 5% on the outside. And for isotope ratio mass spectrometry, the precision better than a per mil is pretty easily attainable. So that's kind of a snapshot of where we are in terms of using mass spectrometry in the CCQM, particularly in these two working groups. Mass spectrometry, I might mention, is also used in some of the other working groups, as you would imagine. But those are not really in view today, although they could be if we wanted to develop that topic, they certainly could be. Okay, so what is the CCQM view on measurement of radioisotopes? This is really what I wanted to finish up with. The CCQM really has never considered radioisotopes as part of its domain. Now that's not on paper anywhere. It's never been written as far as I've seen. There's nothing that says that we don't measure radioisotopes. We just really never have. It's never really been discussed. The only radioactive elements that we ever really measure are those which are essentially stable. In other words, well, as Lisa said, everything is radioactive to some extent, but there are radioisotopes of just about every element system. But if the radioactivity is going to interfere with our measurement, we typically don't do it. And a lot of that, I think, comes back to the special handling and safety considerations that go with radioactivity. And most of our NMIs and DIs, the National Metrology Institutes and designated institutes who participate in the CCQM, the particular laboratories are not really set up to handle that. So that's probably the practical reason for this. But that having been said, though, we have decades of mass spec experience that can apply to measurement of radioisotopes with special considerations taken into account, such as accounting for the radioactive decay that might happen during the measurement. So I've seen some good examples of how that is done just in the past few months. So the CCQM certainly has an interest in this, so we just have to work with the CCRI Section 2 to be effective in collaborating. So our initial steps then in this interaction, we're holding this workshop today. Lisa also mentioned a couple of previous events that took place leading up to this workshop that I did not place on this screen. As a first activity, the CCRI Section 2 is invited to participate in a key comparison that we have going on right now that's just starting up in the CCQM, which is K178P223, rare earth elements, uranium and thorium in soil. I will emphasize that the measurements here are the elemental mass fractions. We're not really set up to measure becquerels. So there has been some interest from some of the laboratories involved in the CCRI, but it might not be of very broad interest because we're not set up to measure becquerels for radioactivity. But I'm sure as this workshop goes on this week, and in subsequent discussions, we will find many potential areas of common interest, and the CCQM looks forward to a fruitful collaboration with the CCRI on this topic. So that's all I have to say.